said monastic. James has said it's become the monastic.
Okay, welcome everybody to the second and last talk of this day. This is Jonathan Schaffer from Rutgers University. The title of his talk is Monistic Structural Realism.
Thank you, Fred, and thank you all for coming out here today. When the conference program was first circulated, there was a rich and insightful typo where my talk was entitled Monastic Structural Realism. Insofar as I'm going to be taking a deep dive into metaphysics, that might have been a more fitting title, so I will be reconsidering the title for future presentations. What I want to talk about is the presentation of a kind of positive way to make sense of ontic structural realism in the sense of giving a coherent metaphysical interpretation of the claim that in some sense all there is structure or structures fundamental. So I'm not claiming that this is the only way to give a coherent metaphysical interpretation. I'm not even here claiming that this is the best way to do it. I'm not really going to have time to engage with other alternatives, so I'll briefly note some that exist. I'll just try to be presenting a positive interpretation and saying that it's a good way to understand certain claims that are made about how current physics is revealing a kind of priority of structure. So in section 1, I'm going to be talking about a certain kind of motivation for structuralism that emerges from the thought that in quantum mechanics and general relativity, we're seeing a kind of surplus mathematical structure in the models that we're given. And then I'm going to make a kind of conditional metaphysical claim that says, like, if these ways of understanding what's going on in physics are correct, and I'm just going to take that on faith for the current talk, then how should we try to make sense of the metaphysical picture of the world that emerges from those things? And then I'll talk about ontic structural realism, some existing ways of thinking about it, and I'll try to formulate some desiderata for coming up with a good metaphysical view that fits the structuralist slogans. I'll only give a couple, and I would welcome the opportunity to think through more just sort of general constraints. It needs to be useful for all of us engaging in the literature to have like a checklist of constraints, like here's the 7 boxes you need to tick off to count as having a good, or like here, get as many as you can to count as having like as good as possible a metaphysical image of structural realism. So I'll just give 3, and then I'll present in the third section a view that kind of marries ontic structural realism to the kind of priority monistic view that I've been developing elsewhere, on which the whole is regarded as ontologically prior to its parts, and the whole cosmos is regarded as ultimately fundamental, with derivative subsystems being regarded as secondary fragments of the whole. So I'll try to say how this kind of cosmos first view, where we also assign the cosmos structural properties, makes good sense of structural realism. So I just want to flag very quickly that structural realists have very often moved quickly from the claim that all there is that structure is emerging as crucial in physics to looking at relations. And I've never quite understood how that transition from structure to relations happened so fast, but I'm going to do things differently. I'm going to look at structure in terms of not relations among the parts, but structural properties of the one whole. These are going to be intrinsic properties of an object. So in that sense, flagging some of what's to come, this interpretation is going to be preserving a very classical metaphysical picture in which what's fundamental are objects, I guess in this case just one object, bearing intrinsic properties. So let's go forward. So I'm going to go fast through these motivations, I'm just really trying to report claims that are made in the literature. First claim, so classically, if you've got two particles freely moving between two boxes, there are 4 equiprobable cases. They could both be in the first box, they could both be in the second, or you could have particle 1 in the first box, particle 2 in the second, or particle 2 in the first box, particle 1 in the second. And these get treated equiprobably, 25% each. But quantum mechanics, at least for duplicate bosons like photons, according to Bose-Einstein statistics, there's only 3 equiprobable cases. They're both in box 1, they're both in box 2, or, and now we collapse this to the one boson per box picture. So, this move to Bose-Einstein statistics is said to motivate the idea that we need to collapse different models of the same reality. So if we are, I'm doing now just a very crude model of quantum mechanics. This is not a serious model. I'm just imagining we're going to have 2 photons and 2 boxes. So if you thought that that's how we're doing our model, so we've got a set of objects, our 2 photons, and then we've got assignments of the objects to locations, which boxes that they're in. We've got 2 mathematically distinct models. The model 1 here assigns photon 1 to box 1. Model 2 assigns photon 1 to box 2, and then flips over where photon 2 is. Mathematically, these are distinct models, but insofar as we wanted to, for our bosons, collapse this into one, we want to say that in some sense these models are they're mathematically distinct, but representationally, they're representing one and the same worldly situation. And it's sometimes said that this marks some departure from classicality that we see in quantum mechanics. I hope I flagged over and over again that I'm just taking this on faith. There's a lot of parts of this argument that I'm not happy with. I think Nick Huggett has very convincingly argued that this is not the right, that even in the classical regime you get this kind of behavior. I think also, I've been trying to flag this is only true for bosons that obey the Bose-Einstein statistics. It's not true for fermions that obey Fermi-Dirac statistics. So if this collapse is supposed to represent some kind of loss of individuality, it's only for the bosons. And the fermions, if any collapse is happening for them, it's not for this reason. I'm not going to worry too much about how far this argument goes. Myself, I'm happy to collapse all of these, the classical particles, bosons and fermions into a kind of monistic picture in the end. So I'm happy in the way that I come to think about things, to think it all gets covered equally. And that's especially useful, throwing in a lot of fun now, if you want to think from a structuralist perspective, that there's a lot of continuity in theory change, from classical to quantum structures. And also if you want to think that fermions and bosons are similar in important ways. We don't want the sort of fundamental bosonic structure of the world to be this radical all-structure thing, whereas the fundamental fermionic structure of the world is individual particles. That would be weird to have such distinct treatments. Okay. And again, just reporting. So general relativity, given general covariance, for any general relativistic model, which I'm going to articulate in terms of a 4-dimensional manifold, 4-dimensional continuously differential manifold, a metric field, and a stress energy, or I'll call it the matter field, and any diffeomorphism. This is a picture from John Norton on the Hull argument, where he's sort of illustrating what a diffeomorphic transformation does. It sort of smoothly sort of twists and slides some values, some field values along the points. So if we have a given diffeomorphism F that's taking our same manifold, but now we're looking at the action or the pullback of the diffeomorphism on the metric field and the matter field. This is also going to be another GR model. These are models that are said to be in a common orbit. So the take-home point, what we're supposed to get out of this, is that given Leibniz equivalence, we're supposed to say that we've got these two models, M1 G1 T1 and M1 F on G1 F on T1, are mathematically different if it's a non-trivial diffeomorphism. So we've got mathematically different models, again, but they're supposed to be representing one and the same reality. So the common moral that's said to emerge from looking at permutation invariance in quantum mechanics and looking at Leibniz equivalence in general relativity is that our existing mathematical models have surplus structure. We've got too much, we're getting these fine-grained mathematical differences that aren't supposed to correspond to metaphysical differences. Right. So maybe, again, it's said that we have a unified moral. We have mathematically distinct models that are merely notational variants. And so you might have thought, and like if you wanted to be a good empirically informed metaphysician and go to our best science and try to the best extent you can, read off your ontology, that you'd look at the models and you just see, oh, okay, this model says that there is a manifold of continuum many points with some fields smeared on it in general relativity. This model, quantum mechanics, says that there's some, maybe it says there's some particles and they've got certain quantum states or something like that. And I thought, oh, okay, that's how I'm going to try to read off the ontology. But now if the models are thought of as having this surplus structure that's not representing reality, now the question arises, how do we read off the ontology from the mathematical models if there's some extra stuff in there? And a natural thing to think, I'm just going to flip back for a sec to some of these models, is that, oh, okay, we want to think of things in terms of an equivalence class of models. It's a very natural thought. I'm correct about that. But what's that? Like, I get what the world would be if it had some points and some fields smeared over them, or I get what the metaphysical picture would be if we had some particles and some states assigned to them. But what is the world like if it's an equivalence class of these things? It's just what's out there in the world becomes mysterious. And of course, we can take the kind of attitude that some physicists take with respect to the measurement problem and here elsewhere of just, well, shut up and calculate. But I hope we'd like to try to find more illumination if we can. So how can we read the ontology up? And before moving on at the end of this section, I'm going to try to go fast because I know it's late in the day. I just want to flag some assumptions made and unmade going forward. So I am assuming that quantum mechanics and general relativity, that their models have the kind of surplus mathematical structure as described. If you think that's not the best way to think of the situation empirically, very well then this talk is conditional on a particular understanding of physics that maybe ought to be superseded. I'm going to also assume, I think this is important because in the early structuralist discussions, there was a lot of hostility. The structuralists were like, analytic metaphysics should be defunded, and the metaphysicians were like, these people can't even say anything coherent. And it was all kind of nasty, and I hope we can I think the literature is now coming to more of like a mutually appreciative situation where like, hey, we can actually cooperate and like help each other. Like the metaphysicians could stand to learn some more physics, and maybe the physicists could think about some of the models and structures that the metaphysicians have set up. But what I think is going on here is we've got all the empirical info, all the relevant empirical info to hand. We've got permutation invariance in quantum mechanics, we've got general covariance or Leibniz equivalence in general relativity, and now we're looking at making sense of it metaphysically. We've used up the empirical info. All that remains is metaphysical theorizing to the best of our abilities, guided by general constraints of metaphysical theory choice. So, if there's something wrong with doing metaphysics, then we're just stuck here. We'll just never get any further from saying, okay, we've got these models that have this surplus structure. To the extent that we want to go further and illuminate what that's saying about the world, there's nothing left to us beyond using the metaphysical toolkit. Last two things. I'm not assuming anything about classical regimes, as I flagged when I was talking about permutation invariance. Actually, I think there's probably a lot of surplus structure there too, and I'm quite happy extending my monistic treatment very far over these two. And I'm not assuming these are the only motivations for structuralism. These are all the only ones I'm going to discuss. Stevens, for instance, goes in for underdetermination arguments. I'm just not going to talk about these here. There's arguments coming from Worrell about epistemic motivations for structural realism, which James then says, well, guided by naturalism, we should then take this to the argument of what's reality. I'm looking at structuralism as guided by the seeming surplus structure found in quantum mechanics and general relativistic models. Okay. So that was the first section on surplus mathematical structure. Now I'm going to run through kind of ontic structural realism, and then we'll do the monism stuff. Okay, so here's a quote from James's SEP article giving a kind of overview of what ontic structural realism is about. I'll just read it. Ontic structural realists argue that what we have learned from contemporary physics is that the nature of space, time, and matter are not compatible with standard metaphysical views about the ontological relationship between individuals' intrinsic properties and relations. On the broadest construal, OSR is any form of structural realism based on an ontological or metaphysical thesis that inflates the ontological priority of structure and relations. So that's sort of the general thing that we're doing. I'm actually not sure whether my view ought to count as structuralist under James's construal, because my view is preserving the standard view that we've got individuals bearing intrinsic properties at the fundament, just one that you might not have expected to find, the big one of the links. And it's not inflating, it is inflating structure, but through structural properties of the whole, not relations. But I do think at the end that the view that I put forward will just feel recognizably structuralist. But I leave it to the structural experts in the room, of which there are many, to tell me whether that's so or really so or not. Okay. So, but of course, like James has been putting forward these theses, as we all know, the literature has been filled with the haters who are saying, what are you talking about? What does this even mean? And so I've got a few representative quotes from Walter Pooley, Hilary Greaves, and a more recent one from David Glick, who I think is starting, we see now, sort of by the time we get to Glick's article, this sort of more cooperative attitude of, okay, look, let's just try to, make some good metaphysical sense of this. How can this slogan be turned into a worked out metaphysics? I also want to note that Hilary Greaves was calling for a 10-year moratorium on structuralism. That was 2011, but given the slow rate of publication, she probably wrote those words around 2009. So I'm thinking by Hilary's lights, we're okay now. So Fred, well timed. As many of you know, structuralists have worked out some different ways of understanding structural realism. The dominant ways of going, in fact, like often if you look at the taxonomies in literature, they're all looking at the relation-based way of going, because there's been, as I noted earlier, this very quick move from like elevate structure to look at relations. The sort of radical version of the view, Stevens defended, James has defended. I don't know where people have landed nowadays, so you can tell me if you've moved to different views or not. We understand structure in terms of relations, and we say that only the relations exist. There are no objects at all. I guess there's a sort of a slight variant of that view that says there are objects, but they only emerge as positions in the relations. And then there's this version Asfelt and Lamb give, where they say this is moderate structural realism, where objects and relations are co-equal. I mean, that's a sort of view that actually looks very traditional to me, because almost all metaphysicians have some fundamental objects and some fundamental relations too, as Aristotle himself would have told us. I think what's actually more distinctive about the Asfelt and Lamb view is the denial that the fundamental objects have any intrinsic properties. That's actually really what sort of separates it, I think, from more traditional views. But there's some different ways of thinking about structuralism. So Shamik Dasgupta has presented this view, a sort of kind of generalism, where we write we write down the facts of the world not in the sort of standard individual invoking languages that we all know and love, but something like Quine's predicate functories language. So this is we can think of Dasgupta as not really working directly with relations, but working this kind of Wittgensteinian idea that's the world of facts, and thinking that the proper language for writing down the fundamental facts of the world isn't sort of standard logic with terms for individuals, but predicate functories, so the fundamental facts are these individual free general structure facts. But we don't need to stick to relations or facts to get an implementation of structuralism, and as a metaphysician, I can tell you the toolkit is rich. There are many other things we can play with, and we can also play with properties. As a way of understanding structure. One way of doing it, and this is Laurie Paul's work on mereological bundle theory, looks like this. So we say that only properties exist. But there's another way of going, which is how I'm thinking about it, where we say what's the fundamental properties are structural properties, and they're ultimately, it's a further step to say that the structural properties are structural properties of the whole in the final analysis. You could just say that you could kind of be a bundle theorist at that point, just say, no, there just are the structural properties, and they're not instantiated by anything. Or you could, I don't know, you could play around with that. But I'm just going to take for granted, I'll talk about it briefly later, that the fundamental structural properties are going to be ultimately best understood as structural properties of the whole universe. And so we're looking at kind of universe first, whole with a W, first views. So we're looking at a certain kind of monistic picture. And I'm not, as I mentioned, I'm not going to try to criticize alternative views here. I never get to my own, and I'm not even relying on the claim that this is the best interpretation, but only one of them. But as I was flagging at the beginning, it'd just be useful to have a checklist of some good-making features of any alleged metaphysical interpretation of ontic structuralism. So, without any pretense to exhaustivity, here's 3 things that I came up with, in part because they were also 3 things that I felt I could manage. So this wasn't maybe biased list. First, a successful interpretation should be recognizably structure first, or give structure some strong priority, and it should integrate that within a generally coherent and plausible ontology. It should be clear, make sense. I think bonus points if you're very conservative, just by general methodological principles of conservatism. And as flagged, I'm going to be in a certain way, very conservative. Object instantiating intrinsic property. In a certain way, you might think monism is very non-conservative. It's a radically revisionary metaphysical hypothesis. I won't go into this much here, though I will say that if you think that, I think that you may be mired in the parochialism of the last century of analytic philosophy, in which it's true that monism had a terrible time. It was a rough century. But if we take a broader view and look over the wider history of philosophy, going back to Father Parmenides, and looking at Plotinus and Hegel and Spinoza, Bradley, blah, 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 there is a rich history of monistic thought in metaphysics. Arguably, I think actually the dominant view in the history of the topic. So I think it's actually very conservative. And you may not be convinced by that. Secondly, a successful interpretation should entail permutation and variance in quantum mechanics and Leibniz equivalence and general relativity. And I'm only saying that because I was taking those to be the arguments dragging us into this kind of structural discussion. If you take whatever the more general thing to say is, whatever considerations you took to motivate your structuralism, they better come out supported by the interpretation that you did. So if you went in thinking that underdetermination was the route to structuralism, then your interpretation of structuralism had better yield that you get that kind of underdetermination. And thirdly, I mean, I think there's a sort of a general mindset of structuralists, and I, myself as well, I think probably most of us in the room, that we generally want to sustain a naturalistic metaphysics and take our empirical information from the sciences to the extent that we can. So if there's any other constraints that are coming from the physics, we want to fit those into. We don't want to, like, if you could imagine, don't ask me how this would go in detail, you could imagine someone coming up with like, oh, structural realism, like, as astrology fits 1 and 2. But there would still be like something very amiss about putting forward structural realism as astrology. It wouldn't fit the kind of general, empirically informed mindset that we want to be taking. Oh, so how am I doing on time? I've lost it.
Excellent.
Oh, oops. Yes. Ah. Oh. Here comes the monism stuff. The key idea here is we're going to understand structures, not in terms of relations among the parts, but in terms of properties as a whole. So here I'm appealing to the notion of a structural property, which those of us schooled in the monastic traditions of metaphysics will hearken back to David Armstrong, probably goes back way earlier. And so we see it discussed, for instance, with the property of being an H2O molecule, where the property of being an H2O molecule is the property of a, medium-sized thing, molecule. And it's a property that a thing has when it has at least 3 parts, 2 H's and an O, arranged and bonded in the right ways. So it's a property of a, not the biggest whole, of course, but it's a property of something that's got some parts, little hole, property of a little hole, that entails that that little hole has some parts and that the parts are arranged and have certain features. Or to take another example, which I get from Josh Parsons, and which I tend to use in my own thinking, we have the property of being polka dotted. This is Yayoi Kuzuma's Polka Dots Madness #6. And polka dotted room. If we think about, we just take, this is a little bit, couldn't resist putting up the picture, but it would be much more helpful for my purposes to have a very simple example of like a clean sheet of white paper with, say, 3 red polka dots in a certain arrangement. So that sheet of paper with the 3 red polka dots has a particular color distributional property, or I'll say color structural property. It has the property of being polka dotted in a very specific way. We don't have a term in English or probably any other natural language for that exact way of being polka dotted, but there's an exact way of being polka dotted that that paper has, in which duplicates of that piece of paper will share. They will have those 3 red dots on a white background where the red dots are shaped as they are and the 3 dots are arranged as they are. So in the case of being an H2O molecule, what bears the property is the whole molecule. In the case of the polka dottedness of Yayoi Kuzuma's room, it's the room that bears the polka dottedness property, or in the simplified case of the sheet of paper with the 3 red dots that I just asked you to imagine, it's the whole sheet of paper that bears that property. So what bears the structure is a whole object, and of course if we're talking about, so I say, as I mentioned earlier, you can play with that if you don't like this classical picture of properties instantiated by objects. I like it. I think the most relevant point I can make here is that nothing in structuralism, at least as I'm interpreting it, is pushing us away from that picture. So So if we're looking at the structural properties of the whole system, then the bearer is going to be the whole system or the whole cosmos or the universe, the whole shebang. So structure is thus, as Catherine Hawley puts it, the internal structure of a larger object. It's also an intrinsic feature of the bearer. So what we're looking at here is an opportunity to understand structural realism in terms of properties of the whole. I should mention that I'm not the only one who's had this idea that we can wed structural realism to some form of monistic view. Catherine Hawley's played with this idea. Terry Horgan's played with a version of this idea, although his monism is quite a bit different than mine. It's the blobject, which has no parts or properties. And as you can see, I'm directly appealing to properties that entail having parts. So it's a bit different, but it's in the similar vein. Stephen has looked at Terry's blobjectivism as a potential viable interpretation of ontic structural realism. Oh, and Dustin Lazarovici, maybe apologies if I got that name, mispronounced the last name, and some unpublished work has looked at general relativity through the lens of priority monism and tried to and says that we can make the best sense of structural realism in this way. So what I now want to do is just tell you how to think about quantum mechanics and general relativity through the lens of monistic structural realism. And I should clarify, the goal here is not to rewrite the physics in any substantive sense, but just to interpret the kind of structures that are coming from the physics as structural properties of the world, and see how doing so can get a certain kind of equivalencies that we wanted to capture. So here's the fundamental ontology according to the monist, according to quantum mechanics. So if quantum mechanics is the true theory of the world, presumably it's not, but we're just looking at what that theory says. The monist will tell you that the fundamental ontology is simply this. It's the universe being in a certain quantum state. Yes, I would prefer, well, we can think of this in terms of the time-dependent one, and we can think about the universe being in a certain quantum state at a certain time, say the initial conditions and evolving. We can also think about this in terms of the time-independent quantum state of the whole block. I'm trying to get away from disputes about how to think about time. We can do it better. And I should say that this is not an alien perspective for a lot of physicists, from what I understand. I was actually emailing with Heinrich Pace in Dortmund, who has a recent Scientific American blog article about how quantum monism can save the soul of physics. And he tells me that we see this attitude in physicists like Carl Friedrich von Weizsäcker, who says if there could exist something which could be understood accurately as a quantum mechanical object, it would be the entire universe. I just think we see this in Everett, and we see this coming out of entanglement considerations. So if we're looking at a whole system, the whole universe in the end, it's going to evolve, and we're realist enough to think that it has a wave function and quantum mechanics applies to the whole universe. We're going to think that it simply evolves according to Schrödinger's equation. But if we're looking at subsystems, given pervasive entanglements, then we're losing some information when we talk about the subsystem. And so we're not really, we have to say something about how to even think about making sense of subsystems. So Everett has this idea of going in for relative facts, where the universe being in a quantum state is the fundamental reality, and then measurement and how things look to observers comes from looking at these relative facts. I should flag here, often interpretations of quantum mechanics are asked to solve the measurement problem for good reason. That's a hard problem. I'm taking what you might think of as a somewhat perverse attitude. I'm not trying to solve the measurement problem here, but trigger it. I'm trying to give a way of understanding quantum mechanics. And insofar as quantum mechanics triggers the measurement problem, I'm trying to trigger the measurement problem. And now we'll have to do some things to try to solve it. We could just stick with the fundamental ontology as given, and then I think we're going into an Everett-style interpretation. And then we'll need to bring in like relative facts, or we can talk about sort of different stories or branches, if you like. I'm not crazy about that way of thinking about it. Or we could add some stuff. We could change the evolution from Schrodinger to something more probabilistic, to go into a Girardi, Rimini, Weber. Or we could try to do something Bohmian. And actually what that will look like here isn't adding in particles, but actually adding in a second property, of a kind of particle distribution property that's going to be correlated with psi through the guidance equation. That's a little messy. That's why I don't have enough of work. But again, here I'm just trying to trigger the measurement problem, not solve it. And just to give you a little toy picture of how this works, consider a famous example from Einstein, Podolsky, and Rosen, singlet state. So imagine we just have a little mini world. We've just got these two particles that are anti-correlated with respect to, just going to say spin. I'm trying to suppress technicalities wherever possible. I'm not going to bother saying like, oh, in the x orientation, we can work that out. But they're anti-correlated in an interesting respect. I'll just say with respect to spin. And so in a little EPR world, we just say that the universe, the monist says the universe has this property. And this is a structural property. It's the property of having two particles that, given the correlation coefficient in play, are opposite in spin. So they can be like, we can have down-up, or we can have up-down, but we can't have up-up or down. So that's what that structural property of the cosmos says. And I guess I went through this earlier. Schrodinger's equation describes the evolution of the quantum state over time. So we see people like Tim Maudlin saying, oh, the laws of physics, they describe the evolution of the world through time. So this is a very literal rendition of Maudlin's view of the laws. Schrodinger's equation describes the evolution of the quantum state over time, and very literally says how the world changes over time. Okay. So now I'm going to claim that this interpretation of quantum mechanics meets those three desiderata that I adduced earlier on good metaphysical interpretations of quantum mechanics. It integrates a property-based understanding of structural realism into a classical monistic ontology that, from the perspective of a metaphysician, maybe you think it's radical or controversial, but it's at least, from a metaphysician perspective, it's clear what the ontology is. And I was saying earlier that I thought the view was recognizably structuralist, even though it's not inflating relations. So I just included a couple of quotes from S. Felton Lamb, from Stephen, and from Mauro Gerato, who seem to be saying that like structuralism goes in a holistic direction, and that it could well be understood in terms of Huygens' object. So I would like to think that my sort of priority monist picture, which is quite similar to Huygens' object, except for including the very properties and parts that are needed for this implementation, would equally deserve to count as an implementation of structural realism. How do we get to permutation invariance? Well, it's very clear. The property that we're assigning is the same if we're assigning, in the case of the flipping the particle inverse. So if the only property in play is in the EPR case, having two particles opposite in spin, or to go back to the particles freely moving around boxes, in the case that I started with, the property of having one particle per box. That's the same whether we label the derivative particles Alice and Bert or flip their labels. If we think of these structural properties, these are qualitative, so they're not including the labels. So if we think about what it looks like, so let's say we've got the two, here are the two boxes. And we think of our particles as little dots, so I just want you to visualize a dot in each of the boxes. That's the picture of one particle in each box. Flipping the part, now imagine, if you can hold this image in your head, flipping the dots around. So the dot that's in this box moves to that box, and the dot that's in that box moves to this box. I hope you can see you've wound up with the very same picture. Qualitatively, nothing's been changed. And finally, I'd just like to, this is going to be more of an advertisement than anything I can seriously defend here. Monistic structural realism for quantum mechanics, I think, does cohere well with other empirical constraints coming out of quantum mechanics, especially the kind of holistic constraints coming out of quantum entanglement. This is something that Janan Ismail and I have some co-authored work on that I would just refer you to if you're interested to hear more about how I think that goes. I've got a quote from David Glick that I put up here instead of quoting myself. So Glick says, the holism urged by structuralists, often motivated by quantum entanglement, is an ontological holism. It seeks to regard wholes, for example, compound entangled states, as ontologically prior to their parts, for example, entangled particles. I think here David is maybe guilty of reading structural realists as if they were just all priority monists from the start. But I only want to say that I feel that these pictures cohere so well together that David could be excused for thinking it was just a single picture. How am I doing now? Good. So I'll say a little bit about general relativity, though this will be a bit. So again, we're going to assign structural properties to the universe, and again, we're not seeking to transform the physics, but just to think about what the models have been giving us as in terms of structural properties of the whole. So now we say, instead of just taking models with manifold, a metric field, and a matter field, we say the universe has the following structural property. Much more complicated than an H2O molecule. It's got the structural property of having continuum many-points, arranged in a four-dimensional, continuously differentiable manifold, and infested, or smeared over, painted over by metrical and material fields. So we're now thinking of this as the structural property of the whole. We have Einstein's field equation. It says how the metrical and material fields are coupled. And so this one is saying how these features of the world are locally correlated. So this is more of a correlational law than evolution. And what's important is that this structural property of the universe is preserved under the relevant sorts of coordinate transformations. So what's important is that diffeomorphic transformations of this structure, just like in the quantum mechanical case, where particle permutations preserved the picture of one particle per box, what we want is to give a kind of qualitative picture, a structural property that's going to be preserved under diffeomorphic transformations. So let me now say how I think the desiderata, the three desiderata that I've given, maybe I missed some that are important, how the three desiderata that I've given are. First, for the same reason as before in the quantum mechanical case, we've integrated a property-based understanding of structural realism into classical monistic ontology. So we've got a metaphysical integration. Secondly, if we set up the property correctly, then we'll get a property that's going to entail Leibniz equivalence just by being preserved under diffeomorphism. This is something that I mentioned Dustin Lazarevich's work earlier, that he's worked out in detail, and I'm just going to quote him here. He says, the metaphysical framework that captures these insights about general covariance, Leibniz equivalence, is priority monism. And he says, taking the global structure as primitive, which is what we're doing, implies, in particular, a Leibniz equivalence of diffeomorphic space-time models. This is to say precisely that two space-times, that's given by this manifold and this metric field, that manifold and that metric field, are identical if and only if they instantiate the same structure. So we're identifying these representationally distinct things as being of the same reality, even though M and N may differ qua set theoretical objects, and the metric fields F and G may differ qua metric fields. So finally, we are cohering with the empirical constraints of general relativity, and here I want to mention something that what I'm about to say may merely reflect my ignorance of the literature. Apologies if so. But one of the things that strikes me when I look at the formalism are, but I don't see talked about so much in literature, are continuity requirements on the field distributions. So in order for the structures given by the metric and the matter field to make sense, to be interpretable in the right mathematical ways to support structures like geodesics and things like that, we need the metric field to be continuous, to be smooth. And that's a holistic constraint on the total distribution of the metric field over the points. So if you started with a fundamental ontology, which is maybe natural enough before the structurals and stuff comes, or you're just thinking of like, oh, I've got a continuum many points with some fields on them, you're thinking of the fields as just mapping properties to points, then you're starting with an ontology that makes it very hard to enforce any holistic constraint of continuity on the distributions over the points. So if what's fundamental to the world is just, oh, this point has that property, and neighboring points around it have these various properties. And if you have anything like free recombination going around, and these are all just little fundamental bits of B, then you should be able to just freely recombine the point values. But you can't do that, at least in a mathematically sensible way, without breaking the structure that gives you geodesics and like a lot of the important metrical structure in general relativity. So there are these holistic requirements on the distributions of the fields that we need to get the mathematics working. And I want to say that the monistic structural realist interpretation of general relativity not only fits Leibniz equivalence, it also fits these further holistic constraints that are very hard to get from an atomist point-first perspective. So, that's it. Thank you.
Okay, we have another 1 or 2 minutes. You can formulate your question in your mind clearly and convincingly.
One or the other.
Okay, let's do the hands again. Who wants to ask a question? I start with 1 this time. 1, 2, 3, 4, 5, 6, 7. David.
Thanks, that was really interesting. I'm trying to figure out exactly what problems you think the monism solves, and in particular with respect to the equivalence issues that you started with. So there was a general question. Someone says, well, particles are opposite in spin. That's the structuralist says. Non-monistic structuralist says something like, the particles are opposite in spin, and that's all you can say. It's just a structural fact. You say, well, here's what's really going on. There's the universe, and this has the property that there are two particles opposite in spin. And is that sort of somehow meant to make it easier to grip how... somebody might have had the intuition that, well, it's kind of hard to see how there are two particles that are opposite in spin could be a fundamental description of the universe. Maybe you want to know whether they're Alice and Bob, or whether they're up and down, and just that mirror structural. I don't really have a grip on at least how that could be a full fundamental description of the universe. And you come and go, well, here's the full fundamental description of the universe. There's the universe, and it has the property that it has two particles that are opposite in spin. And I'm thinking whoever had the first reaction might have exactly the same reaction to the monistic version, which is how could that be a fundamental property of the universe? The universe just has two particles that are opposite in spin. If I felt before that I wanted to know what the particles were, or whether it was up or down, I felt the same thing about the holistic property. What do you mean the universe has two particles opposite in spin? Well, which particles, and which one's up, and which one's down? So, the basic worry here is you can either say, the universe has the property that, P is the case. The universe has the property that P, or you can just say P. And the question is, what's the extra cash value we've got by saying the universe, instead of saying there are two particles, blah, 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 saying the universe has the properties, there are two particles, blah, blah, blah. What is the extra oomph it's giving? I understand it's a coherent metaphysical view, and if all you're trying to do is articulate a coherent metaphysical view that's no worse off than the others, then fine, but what is the added explanatory value you get?
So, thanks. So, first, I was just trying to formulate a coherent metaphysical view, but I think what your question reveals is something that's true about what's going on here, which is that the monism really itself isn't doing so much work. The real work is done by the structural properties. And then there's just, and I was flagging this as a choice point, you could say that the structural properties are just sort of free-floating, uninstantiated things, or you could say that they're instantiated in some surprising way, like maybe they're all instantiated by my notes.
So sorry.
That would be a view that we could play. It seems to me that the natural thing to say when we think about examples like being an H2O molecule and being a polka-dotted sheet of paper is that the instantiators of those properties are the wholes, the H2O molecule and the sheet of paper. So the monism really is just coming in the background as what I'm thinking of as the natural choice for the instantiator of the structural property in question. But what I want to acknowledge is the separability of first the claim that we should understand structural realism through these structural properties. That was the main claim that I was defending. And second, a kind of follow-on claim that we should think of these structural properties as born by the fundamental cosmos, which is the monist part.
So I'm happy to go with the saying they're instantiated by the cosmos. I'm also happy to go with the structural properties. I guess the question is what is the problem that this view is solving? And I mean, in particular, motivated this through these equivalence issues. It's kind of hard to see how these two, what look like apparently distinct configurations of the world could be absolutely the same situation in reality. People have that kind of reaction to some structural realist claims. The question is, doesn't that reaction, I thought initially that you were going to be presenting monism as a view that would somehow solve that problem, but the question is, does that problem arise equally for structural properties? It's hard to see how, instead of saying it's hard to see how this could be a fundamental description of the world, there are two particles opposite in spin. It's equally hard to see how the universe could have the fundamental property of having two particles opposite in spin.
So maybe what I need to do is say more about what I take the task of metaphysical theorizing to be, and this is going to be somewhat idiosyncratic since I have kind of idiosyncratic views about how it goes, but I take the task of metaphysical theorizing to be state the fundamental conditions and the grounding laws that together generate the remainder of reality. It's a bit analogous to the physicist's task of stating the initial conditions and the dynamical laws that together generate the rest of history. So what I think is unclear so far in the discussion of ontic structural realism is what the fundamental conditions are and what the grounding laws are. So I'm taking a stab at spelling out what both of those would be. So take the quantum mechanical case. The fundamental condition is the universe having wave function. Yeah, that's already saying a lot. That's to clarify the metaphysical hypothesis in question. Secondly, and this is something I didn't go into here, we need to spell out grounding rules that say if you've got a hole with this kind of structural property, what kind of derivative reality, as it were, emanates out of that. And there I'd want to just say, well, take the EPR case. And I'm not going to try to do this right now in a systematic way, since this is illustrative. If the property is like having two particles opposite in spin, well, you can in that particular case, you can read off some of the mereological properties of the cosmos. It's got these two particles as parts. And you can read off some features of the particles, although in this particular case, all you can read off is that each particle, going through sort of Born's rule, is that each particle is 50-50 whether it's going to be spin up or spin down. You can't read off from the individual particle states that they're anti-collinear. That's
I guess the catch, maybe before briefly, the catch value of the worry is I like some constraints on what properties we get to take as fundamental in this framework. Just say I said, here's the fundamental description of the universe. The universe is in an equivalence class of these 7 configurations, and I give 7 totally distinct looking configurations. That's how the universe is fundamentally. I expect a lot of people have the reaction, though, I don't understand how that property could be a fundamental description of the universe.
Well, actually, that's already interesting since you treated an equivalence class as a property of the universe. I mean, the usual worry is, what does it mean just to say that there is, that if there's an equivalence class? Now you've already helpfully rendered it as a property of the whole. There is a very deep question, which I'm not possibly going to be able to address here, of what general constraints there are on the metaphysical project as I've articulated it, saying what the fundamental entities are and saying what the grounding rules are. I'm kind of holistic about it. I kind of think, well, it's a bit like methodology for finding the laws of nature and finding the initial conditions simultaneously. We want to posit something like best package of conditions that gives us the smoothest explanations for the rest. So I'm pretty loosey-goosey about sort of overall constraints to be imposed from the start. I'm open to the equivalence class property being a property to play with for the universe, but I do think that that's already progress insofar as we are stating clearly what the fundamental conditions are and have the opportunity to try to play around with grounding laws for that.
We move to number 2.
So yeah, it was an interesting talk and very clear. And I appreciate that this is all work in progress, but I guess one thought that came to mind is when thinking about what monistic structural realism for something like quantum gravity would mean, it seems to me a dilemma arises. The dilemma seems to be this. And so in the QM case, you said that the object, right, in question, right, the monism is in the fact that there's a quantum object, a wave function. Right, that's the holistic.
The wave function is a property on this.
The wave
not an
function,
object, it's a property.
Okay, good. It's a property, right, and it's a single property, right? But this is where the monism comes in.
I don't mind it, or we can decompose it. I was thinking it was a single property. The monism was coming in that it's born by the cosmos.
It's born by
The object that has the property is the cosmos as a whole.
is the cosmos as a whole. Okay, so it has a single property. Okay, good. And then,
I don't mind if the cosmos as a whole has multiple properties. It may well. What's relevant to me is that the bearer is that all the fundamental properties
Yeah.
are born not by little particles or little bits, but by the big cosmos.
So the monism is where it refers to the cosmos as a whole, bearing this property, quantum state property.
It's the whole cosmos being prior to its parts. That's what I mean. Different people mean different things by monism. That's what I mean by priority monism.
Okay, so maybe then the dilemma doesn't come up in quantum gravity, but it just seems to me like the problem would be something like this. In quantum gravity, if you apply it to the gravitational degrees of freedom plus matter degrees of freedom, you have some wave function for both, then you don't have a Schrodinger equation, you have something like the Wheeler-DeWitt equation. And it's hard to even say what the structure is, right, of the wave function of the universe, because you don't even have anything like an inner product structure that you normally have.
But the Wheeler-DeWitt equation, as standardly formulated, is a property of the universe as a whole.
Yes, right.
So I
yeah,
haven't
so-
tried to think about how this looks in a quantum gravity regime. This is beyond some of this has already gone beyond my knowledge.
It sounds like it doesn't really pose a fundamental problem for the moment.
I would want to just talk more with you or other people who know more about quantum gravity, and then we would just have to see. I'm open to from a kind of naturalistic attitude, like, hey, maybe this will extend there, maybe it won't. We'll see how it goes.
That's it, Marlon?
Yeah, I mean, well,
Yeah, that is.
I don't want to go into it too much.
Yeah, well, fascinating talk, but Weizsäcker, he said something very interesting, and I wonder if you can give us some background to it, but can you, or can I guess it?
You
Okay,
probably know. You might know them better than
my
I.
guess is it comes from Bohr's Como lecture, very influential. It's where he introduces complementarity. And Bohr makes the point that if you are modeling the system with the Schrodinger equation, then you cannot interact with it. Conversely, if you do allow interaction, then the Schrodinger equation will not apply to it. So, in a certain sense, this was supposed to lead to the conclusion that either you give a causal description or you give a space-time coordinate to one or the other, and so forth. So that seems sort of right to me, in that the only system, given that you can't screen off gravity, that quantum mechanics could apply to exactly has got to be the universe as a whole. I sort of get that. And I also get that we can play with lots of toy universes, and you've been playing with toy universes. When you say the cosmos, it could just be a two-particle system. It could just be a molecule of water. Right, good. So this is my question. What seems to drive this characteristic of mathematical physics, anyway, is to define a system mathematically, you seem to ineluctably have a system of equations that applies to that system, and you can't connect it to another system in the mathematics without an all-encompassing, if you like, system of equations. Something like that seems to be going on in mathematical physics. And I take that to be a very general lesson. I mean, look, take even open quantum systems theory. You might think, well, there you're just modeling a part of the universe or a part of the laboratory. But actually, what you do in open quantum systems, you start off with the total system and you just integrate out degrees of freedom to get down to the subsystem. So this seems a general methodology, and my question to you is, would you accept that that is a part of your motivation, or is this at right angles to the way that you've been thinking about this?
Somewhere in between. It wasn't part of my own motivation in thinking about this. My own motivation just came from thinking about permutation invariance and Leibniz equivalence and thinking, oh, hey, I've got a toy for this. But I like what you're saying, and I would. I don't know enough about work in open quantum systems, but I'll take for it. I would welcome that as a kind of buttressing consideration.
Sure. And just to be clear, when you speak about priority monism, the global thing comes first. That does seem to be very much characteristic of quantum mechanics, and as I just said, I think it's characteristic of doing theoretical physics, period. But once you do start with the total system, you can always talk about parts of that global system, right?
Absolutely.
You're not somehow suggesting that all talk of parts is elliptical talk for the whole. Right?
No, and that's what distinguishes priority monism from the Horgan-style plot activism.
So I believe that there are properties and parts of the world. And when I was interacting with Dave, I was sort of articulating this idea that we want to say what's fundamental, and we want to give rules to say what derivative things there are and how they derive from the fundamental. So it's going to be part of a more fully developed version of this to state grounding rules that say if the world has this structural property, then derivatively there will be these parts and they'll look like this.
Okay, I think Anja is
Yeah.
next.
Thanks a lot, Jonathan. You like this question. It's about wholes and parts. So I just wanted to probe the idea that your monism might be a convenient or a nice exemplifier of OSR. Maybe by testing it against a couple of the slogans that you mentioned that we associate with OSR. So one of them is that structure is all there is, right? And the other is the idea of inflating the ontological priority of relations, even though you said that that was not one that you were considering here.
It's not what I'm vindicating.
Right. So with respect to the first, structure is all there is, right? If the fundamental properties are structural, I guess just as a clarificatory question, is the whole, right, is your monist whole, is it comprised exclusively of the structural properties? Because if not, then it doesn't seem that structure is all there is. Right?
So this is another slogan that I'm not exactly vindicating. I think in addition to the structure, which is coming through structural properties on this thing, there's the bearer of the structure. The bearer of the structure is not itself the structure. It's the bearer of the structure.
Okay, that's what I suspected, but I
that's
just wanted
the sense
to.
in which I'm trying to do things much more classically.
Right.
And I would advertise that as a good-making feature of the resultant view, though it is one that arguably makes this not exactly OSR anymore. I don't know. I guess I think that, I mean, there is the question of like, oh, where exactly are the lines between OSR and not OSR? I feel like this satisfies some of the slogans and not others. I feel like the result feels structuralist to me, but I don't want to argue about that. If you want to say this is a variant, this is like ontic schmuctural.
Well, it is interesting because then ultimately on this picture, what is fundamental isn't structural, which is an interesting exemplification of OSR. But I do appreciate the arguments that you've laid out to show how there can be structuralist consequences in terms of the structural properties of your view. Can I ask you about the other slogan, even though it was one that you said that you weren't vindicating, which is the idea that that OSR might amount to inflating the ontological priority of relations with respect to their relata. So there are a couple of ways that one might think about this, right, in OSR. There's a kind of non-eliminativist way, which is to say that there are things that stand in relations, right? But the ontological, the priority of the relations is somehow greater. There's an eliminativist way to say that, well, it turns out that the things that we thought stand in relations don't really. Maybe they reduce to relations in some way. Maybe they're emergent features of relations. So I wanted to ask you about parts now of the whole, because there are going to be some proper parts of your whole that stand in relations to one another. And it seems as though we're going to need to tell a story about that fits with the OSR slogan that the ontological priority of the relations is somehow inflated with respect to their relata. So I wanted to ask you how you might do that on the monistic picture. Is it going to be eliminativist? Is it going to be non-eliminativist? How would you approach that?
So there are going to be parts, and they are going to be related. But all of that on the monistic picture is living in the derivative ontology box. And all of it, given the kind of methodology I was articulating in the discussion with Dave earlier, is, as I'm thinking about it, going to have to come from the fundamental ontology via the grounding principles, or if you like, the laws of metaphysics. So we're going to need to say what goes in the fundamental ontology box. We're going to need to say what grounding principles are.
Could you speak up?
Oh, sorry. We're going to have, so there are parts and they are related to each other on this picture, but that's all derivative ontology. And so we'll have to say how it is that the fundamental ontology being as the monist has it, and the grounding rules that the monist will provide to fill out the rest of her theory,
how that generates parts in relation to each other in the derivative ontology box. But there'll be no clear sense in which the relations come before the parts. I mean, we could do it that way. We could try, I haven't tried to do it this way. We could think of setting up the grounding rules so that from the whole bearing a structural property, we, at stage 2, derive a pattern of relations. And at stage 3, we derive objects from the places in the relations. That's open, but it's not purely optional in this construction. I was thinking of these properties like having 2 parts or having continuum many parts is just directly, next stage, giving us the parts. So they were in at least as early in the metaphysical construction program.
Right. I think that's really interesting too, in part because I think OSRS felt a lot of, they felt it was incumbent upon them to tell a story about even the things that aren't fundamental, such that it would turn out that structure is all there is, so that, you know, the proper parts of your whole would in fact turn out to be, right, either structural themselves, or they would turn out to be the kind of epiphenomena. They're not, you know, they're merely, you know, emergent features of the underlying structure or something like that. So yeah, in both of those respects, it's interesting to think about whether the monistic picture is OSR or whether it's compatible with some structural features of OSR.
I mean, here's, I think what you're pointing to is yet another feature, yet another slogan of standard OSR that this picture is not vindicated by design, which is it's not, I'm trying to be conservative ontologically. I've got your standard Aristotle-inspired schedule of categories. I've got individuals bearing properties and standing in relations. Just as Will thought before encountering structuralist concerns.
Okay, let's move on. Next one is Carrie.
Yeah, so this is good actually, because this follows on directly from that. So I wanted to ask you more about how you understand the category of objects. You want to retain this thing. So I've been trying to kind of think about why. I've always been a little bit hostile to this idea that monism, priority monism, is like a form of structuralism. And I think the reason that I think that, to me it just seems quite sort of toothless compared to what structuralists have been doing. So you show me a picture with the 3 dots on it, and it's like the selling point is, oh, it's the whole picture that's prior to the parts, not what you thought the parts prior to the whole. To me, this is just a kind of gestalt shift. About where this priority is supposed to lie. For me, what structuralists are doing is arguing that they're not just leaving the parts intact, they're making you think completely differently about the nature of the parts themselves. So it's not like we just have the ontology that we thought that we had and then we start running the kind of ladder of priority kind of upwards or downwards or something like that. What they're doing is kind of convincing you, is getting you to look at the physics, and in so doing convincing you that there's absolutely nothing in that looks, smells, feels like classical notions of an object, insofar as it doesn't have transtemporal identity, right? It's not really that distinct from event state, insofar as it doesn't have anxiety, insofar as the things that you thought were intrinsic properties turn out to be these really complex extrinsic relational things. There's nothing in this picture anymore, that the parts just look and feel, just are different from the way that I initially thought about them. So it's not just rearranging an ontology that I already accepted in terms of which is prior to what. It's much, much more radical than that. And then so, to do that, structuralists have had to say a lot about, right, these are all the things that we take to be built into a kind of classical, philosophically and physically kind of notion of an object. And that's not there. So how do you, as somebody who wants to retain objects, how do you think about objects? And I think you have to do this partly also to say, if what everything boils down to in your conservative ontology is this one object, right? There are certain definitions of object according to which that one thing would not be an object. It's not in space. It's not the kind of thing that can be repeatable, right? So it has all the features that properties have, right? It's not repeatable. It's not in space, and so on. So how do you think about objects, and do you think that the objects of physics in your picture can be thought of in that way?
Thanks, Karen. So I just let me flag from the start, like your an expert on structuralism, that this doesn't strike you as structuralist, then maybe I should say it's a bit of a different view, but one that I would still, before getting on to talk about objects, it's one that I would still flag as making coherent sense of the kind of empirical motivations that have driven some people to structuralism. So maybe you should take me as saying, oh, don't go to structuralism, go somewhere maybe nearby.
Well, this is typically, these are a subset of the motivations. There's a lot more motivations than just these, yeah.
Yes, true, and appreciate. As to how I'm thinking about objects, there's the best thing that I can say, given that I think fundamental categories are not definable in any deeper way, is that objects, I'm thinking of objects and properties in a very classical way as co-implicated with each other. I actually often think in terms of the pin cushion and pins model. So the properties are the pins, and you got to stick them in something, and that's the object. It's the bearer of the properties.
So it's just substances, basically, kind of Aristotelian substances.
Substances to me has a stronger meaning. A substance to me is an independent bearer, fundamental bearer. But
okay, so its objects are the bearers of properties, but they're not independent of something.
some of the so the way that I'm thinking of things, objects are the bearers of properties, but not all objects are fundamental. Not all objects are substances. This is actually a bit of a departure from a standard Aristotelian schedule of categories that actually has a very hard time making room for derivative objects. If you ask Aristotle, like, what is the ontological category of your heart? It turns out to be a very hard question for Aristotle because heart looks like an object, but it's not independent. In fact, in Aristotle's conception, it's actually functionally understood as a part of your whole organism that helps pump blood. So it doesn't look like a substance or anything else. So I don't want to sort of rely too much on Aristotle because there's some things I would revise. But my objects are best understood as the bearers of properties, and they subdivide into, there's some fundamental ones, and as a monist I say it's just the whole, and there are some derivative ones, and as a monist I say it's the parts that are the derivative objects. And one last thing just to emphasize here, you said that the monism is kind of, you characterized it as toothless. And actually I completely agree in the current context, and this also came out when in the discussion with Dave. It's not the monism that's really doing the heavy lifting here. Maybe it's doing some, maybe it's got some teeth in some other discussions. What's doing the heavy lifting here is the invocation of structural properties. And the monism is just the follow-on thought, like, oh, those are properties, and now I'm thinking properties and objects are co-implicated. Properties are my pins, they need a pin cushion. What's the natural pin cushion for the structural properties? And then just like, well, the H2, being an H2O molecule is stuck in the molecule, so I'm sticking these structural properties in the world. So monism is really just sort of lurking in the background. It's so toothless that it's the thing that the teeth are sticking into. The pins are sticking into. It's not one of the teeth.
Okay, thank you.
Okay, satisfied, Carrie, for the moment?
Yeah.
Okay. Did we have another question? Stephen?
I do actually, even though I was going to say it's a nice act of symmetry because Kerry actually did ask the question that I had in mind, but I do have another question if we have time.
Yes.
Thank you. Slightly hesitant there, Fred. So, I'm bothered. One of the reasons I like the cut of Laurie Paul's metaphysical jib is because she does away with instantiation. And I'm bothered by words like bear. And precisely because, you know, and that seems to me it does, in a way, the worry is it does take the monist across the line. Because traditionally, substructuralists have defined themselves in opposition to what? Eddington, Cassira, it was all opposition to substance. And the reason they thought substance was really a no-hoper metaphysically was because of quantum mechanics, primarily. That was there. And in particular, what we now call permutation invariance. So I'm bothered by that kind of talk. And to follow on from Kerry, how does that kind of talk and the notion of objecthood, how does it fit with, say, one way of understanding the relationship between properties and symmetries in quantum mechanics, which a number of us have talked about. So, you know, the kind property being a boson, being a fermion, in one sense just drops out of permutation invariance. These are two of the group theoretic representations, and there's lots of others. That doesn't seem to sit entirely well with the notion of instantiation, that sort of dropping out. If we want to try and capture what's this dropping out in other than mathematical terms. So I'm not unsympathetic to priority monism, not as unsympathetic at least as others are, but I don't quite see how that view of the relationship between, say, symmetries and properties fits with notions of objects bearing properties. I was just wondering if you had any thoughts on that.
Yeah, so first let me just talk about substances and then
Sure.
talk about symmetries.
Sure.
So I agree that the structuralist tradition is hostile to the notion of substance, and this is another respect in which what I'm doing might not count as structuralist, in which I want to say, well, very well, then take me to be saying that there's a nearby view that isn't exactly structuralist, but that can make sense of the empirical motivations that are the real things that should, of course, be driving us, or the empirical motivations.
Sure.
Can make sense of the empirical motivations in a classical ontological conservative. So I think that's a good making feature just from sort of general methodological conservatism. That's a whole other debate. But that's where substance is sitting. As far as the symmetries, I'm thinking of at least the kind of symmetries, I mean, I did want to acknowledge, as Carrie pointed out, and I tried to also acknowledge in my talk, there are other motivations for structuralism that I just wasn't trying to make sense of here. I think the kind of symmetries that you're talking about are really sitting on the kind structure and not anything about symmetries on individuals. So I wasn't doing anything here to try to make any sense of kind structure. I was just helping myself to kind structure. I was just saying, oh, this is a photon, this is a boson, and not wondering where that came from. I think the way that would probably have to go is that the structural property that I would want to assign to the whole would be something that there's lots of different symmetries that we want to try to capture, something that was symmetric in the relevant respects. So I wouldn't want to say assign the whole just like bosonic structure. I would want to assign it some kind of structure that was symmetric across permutations between families of particles. So so how I'm trying to capture these kind of symmetries, I think they're sitting at a different level, not at the level of individual labels that were coming up here, but at the level of the qualitative structure. And I can sort of vaguely see how I would try to make sense of that, but that's another project.
Okay.
Okay, you chew on that a bit, Stephen, and come back to it later in the conference.
Okay. Thanks, Brett.
Maura, final question?
Yes, so, well, the most part of my question, I think it was already addressed. So the last part, it's more a clarificatory question in order to understand this kind of monism. So let's say that we have the whole universe, and let's say that there are two subsets of this, two parts of the universe that are not entangled. Would they count as two? No. Why?
So if they were entangled, I'd have a quick story to tell you about why. They might be entangled, but let's see. What I'm offering in the first instance is just a hypothesis about the fundamental ontology. And so if you want to know my metaphysical, you ask why, so I'm now rooting this through my account of metaphysical explanation. I'm just going to say, why are these two non-entangled subsystems non-fundamental? Oh, it's because they derive their nature and existence from the whole, and that which has derivative existence is thereby non-fundamental. That was a quick story. Now you might wonder, well, what about the alternative metaphysical hypothesis, the non-monistic hypothesis? that just says something like, go to every maximally large entangled system, but no further, and take that as a fundamental chunk of the universe. And that hypothesis will give you, in a massively entangled universe, a kind of monistic view on that universe. But in a universe that has some non-entangled bits, will get you some pluralism. And
we'll close with a quick follow-up by Simon.
If the finger is permitted, I mean, I think the point is that they would be non-interacting if they were not entangled. And two non-interacting universes were, you might as well have thought of two different universes, one after the other. They're just different universes. That would be my suggestion, actually.
Guido?
Yeah, it's related, if not directly a finger. Maybe I like the position because quantum mechanics predisposes me towards holism, but just wanted to suggest a metaphor for the monism aspect, like sculpting a big block of stone. You start with an undifferentiated whole, and then you start carving structure out, and if it's one of these unfinished sculptures by Michelangelo, there isn't any more structure than the one you carved out. I mean, especially if you compare it with a picture of building a statue out of Lego, I think it maybe a metaphor like this helps, or maybe the monism position helps getting over the hurdle of relations without relaxing. How can we have this free floating structure? And it starts from something that's undifferentiated. You just add as much structure as is needed, and that's what bears. Start from the top down, well, that's what that.
Was that a question, Guido?
Was
Was it the closing sermon of the day?
Take it like a picture.
Half-carved sculpture.
Capture some elements of what we've heard.
Well, let's first thank Jonathan again. For the people who came in late, I'm afraid you need to sign a paper to admit that you are being filmed. Okay. You reconvene 9:30
Yep.
tomorrow morning.
You too. You must be. Yeah, but it's back at the hotel.
Oh, is that what Chris said?
We'll all go down there.
The speakers' dinner starts 7:30
Okay,
Where? Where?
next to the hotel.
near Hotel New York. I'm coming with you.
Okay,
Yeah.
we'll be in the lobby, 7:30.
So you're going to be working with Kelly and
Where do you going to go? And the baby? Rodo? For dinner? Excellent.
That was a very nice question.
Oh, very clear, very penetrating. Just the one I would like to.
There is a
a problem, I think, in expressing the kind of intuitions coming from the very radically visionary programs like this in the language of arithmetic physics as it has evolved in our time. And there's a fundamental tension, I think, partly here Steve's question about whether one really does actually have a notion of knowledge at all. Right. One of the things I think does speak to this is some interesting technical work on characterizing structural invariance, for instance, in GR, in capital theoretic terms. That recent meeting they had in Munich in CMT, and that's going to be another but there's a disconnect with time. No, take that.
Oh, is it all right if I wasn't paying attention to how we got from here to okay. But you'll be back tomorrow.
Oh, I'll be around for the next 2 days. Right, yes, I just have to pack this one up and give the recording to Fred.
Right.
No, I'll see you.
Yeah. I was trying to think of actually the last time I saw you. I had a hard time picturing you. It was quite a while ago.
Well, it might have been not last year's, but the year before. I certainly saw you there, but I think I've seen you at least once since then.
Let me work on it.
Well,
I'm sure you can come to me.
it's good enough to see you now, yes. Yes, but will it be Yes. I'm trying to remember how we. Sorry, Christ. I'm just trying to remember how we got this.
Well, most people do anything